Welcome back to another episode of the Beyond the Blueprint podcast, powered by Ferguson Electric. I'm your host, Steven Marcelino, Vice President of Sales, and Ferguson Electric is a full-service electrical construction company covering areas such as residential services, emergency services, energy efficiency, commercial construction, and engineered services/electrical preventative maintenance. And I'm here today with Patrick Mudd, Senior Engineer of Ferguson Electric, Ellicott Engineering. Patrick, thank you for joining us today.
Thank you, Stephen, for having me.
And I know you had quite the journey coming down from Buffalo up there near the Canadian border. So thank you for coming down to be on this episode of Beyond the Blueprint.
Oh, you're great. Yeah, thank you.
So Patrick, aside from your really cool mustache, I think we have a lot of great things to talk about today, specifically for professionals that are in the engineering field, facilities management, industrial data centers, hospitals, kind of the do's, don'ts, and horror stories of our experience in the industry, and what happens when you don't do certain things that are outlined in books such as like NFPA 70E, IEEE, NFPA 70B, the NETA standard. With your experience in the industry and all the different types of facility safety and damage mitigation services that we provide, I think the crux of it all is arc flash hazard analysis. I think when a facility has a proper arc flash, short circuit, and coordination study in play, you can kind of go down the line of the preventative maintenance measures to follow to mitigate electrical fire hazard and building interruption. And I know you're an expert when it comes to arc flash and those engineered studies. So I want to let you kind of just talk to the listeners today about what arc flash is, the importance of arc flash, and how an arc flash program can be implemented in their facility if they don't have one already.
Yeah, thank you, Stephen. I guess to start it all, the arc flash would be where we would like to start. It kind of encompasses everything else with the standards, as kind of we were talking before this. Arc flash is just one piece of it. And then, also everything that's encompassed in that study then relays onto the other standards that you were mentioning, like the 70B, the NETA standard for like your testing of acceptance and like maintenance testing of that equipment. So in the simplest terms, the arc flash hazard analysis, also takes into account per the standard that the stuff has been properly maintained. The doors are working properly, the breakers are operating per the manufacturer specs. So with that, that's kind of like a good, we'll say like a doorway into maintenance and also further testing and conditioning of the equipment. So if we were to kind of start backwards and go to where you were talking about like the arc flash study itself, once we gather that data, whether it's a fuse, a breaker, a relay, all has what they call time current curves associated with that. And those curves are based on that equipment working as it was designed to do. So when the study is done, it is less notified that something obviously wasn't operating properly, or, you go there, they got duct tape all over the stuff, then you're kind of going on the stance that this stuff is working properly, maintained properly, and they're going to continue to do that because the study is the one piece, but then also keeping up with the maintenance, as you well know from recent things, is also the next piece of the puzzle. So all the labels that are applied to the equipment that are done through the analysis are based off of that. I wouldn't call it an assumption, but you kind of do call it an assumption that even if you weren't the first one in there, that before the people that were there before you were doing everything properly.
What's some of the information that safety label from the arc flash study portrays? I could speak on it myself, but, from your expert view, what does that label state? Obviously the PPE, the calorie centimeters squared, limited restricted approach boundary. But on a technical level, what does all this mean to somebody that needs to either analyze the label when they're approaching it, or if they don't have the labels present, what kind of scenario could that put them in?
So I guess I would first like to preface that to the standard. Just because the label's on there doesn't mean that we should be allowing everyone to go into the the enclosure or cabinet's energized. They've kind of really stepped back in the standards with that now, and the energized work is always the first priority. It's up to the client or customer to prove to us that that there's going to be a greater risk of de-energizing that equipment than there is to keep it energized to allow that guy to work in there. So while the label does have those items like you mentioned, prohibited approach, the calories per centimeter squared, and tells the guy what to wear to perform the task at hand, there's also a risk and a hazard with that doing that energized. And I guess I would just like to say that, we should probably always find a way to do it de-energized, because that's always the safest way. But yeah, sometimes, hospitals or certain other businesses, you just really can't take something down, and then it's up to everyone to understand the risks that are going to be taking place before they do any sort of maintenance.
Very interesting. And from, from that view, that kind of discusses the overall importance of an arc flash hazard analysis program, which is one part of the studies that you and I perform together for our clients. Let's talk a little bit about, because arc flash covers safety. At the end of the day, arc flash hazard analysis is a very comprehensive safety study to make sure that the men or women or whoever's approaching the electrical infrastructure, whether they're just turning a breaker on or removing a panel cover to do live work, they're aware of the risks at hand and they can work safely. Because at the end of the day, I think the goal for all companies is to have their employees and the employee themselves, go home safely to their families. I think that's the ultimate goal here. So let's talk a little bit about coordination study, because I know a lot of the work we do together, we're kind of doing the two studies in tandem to give the end user most benefit and the most information about their system, so they know that at any given day and time, their system's operating and they could sleep at night without being worried about, is our electrical infrastructure going to fail us tonight.
The importance of the coordination study, in its simplest terms, is kind of, does A kind of not cross over B? I guess would be the simplest way to explain it. It gets more complicated from there, but to stay on topic, the whole purpose of that is to make sure that whatever is supposed to trip is going to trip when it's intended to trip, and then that fault or trip event isn't going to go past the device that you want to trip and trip something further upstream and cause a further outage to more equipment fed from the same panel or switchboard, or God forbid your whole facility.
To add a little more description to that, and correct me if I'm wrong, really we're making sure that smaller breakers or fuses aren't tripping larger breakers or fuses upstream or tripping equipment that's not supposed to trip in that sequence if there is a failure.
Yeah, we want to make sure that the device below the other device is going to trip before the device ahead of it.
Gotcha. And like you said, the importance behind that is, to make sure that if there is a failure in panel A, like you said, that it doesn't take out panel B or C, or vice versa. That panel D isn't going to take out panel C and B. And I think a lot of times I like to use the plumbing analogy when discussing the coordination study. If you have a pipe that has an inch in diameter and you connect it to a pipe that's 3 inches in diameter, once the water starts flowing through and the pressure builds up, those pipes are going to blow apart. So you really want to make sure from an electrical coordination standpoint that all the breakers and fuses are in proper coordination, or you could say, for layman's terms, communication with each other, to react when they're supposed to react.
Yeah.
Yeah, and I think, like we said, the baseline of maintenance and safety analysis is this arc flash and coordination studies, and we could get really deep into it. I know on our end, we get really into the NFPA 70E. We do the electrical safety training. Once the study's complete and we kind of know what safety hazards the client may be facing, we'll develop a electrical safety plan for the facility as well, to make sure that, there's a program in place, not only on a maintenance side, but on a procedural side, to make sure there's guidelines for the facility engineers or contractors entering the site to follow before they begin working. So, apart from engineered studies, I know a major focus for you is relays and relay testing, whether it's in large facilities, industrial manufacturing, or substations for utilities. Why don't you tell us a little bit about the purpose of the relays in the electrical infrastructure? I know there's a plethora of relays. There's a bunch of different manufacturers and types depending on the function you want that relay to play in your electrical infrastructure sequence. So why don't you tell us a little bit about the more common relays and what their function in the infrastructure are?
Yeah, I would say the most common ones you'll probably find, and there's ANSI symbols to go along with those, are typically your 50-51, which 50 is your instantaneous, 51 would be considered your overcurrent. Um, that those are just numbers that you would usually see on one lines that kind of then tell us what the protection is. 87 would be your differential, and then you could kind of get into reverse current from there, which is 67, and then the numbers I think go into the 90s depending on the type of relay. Um, but for most 70E studies, you're mostly concerned with the overcurrent and the differential type stuff, which would be your standard 50-51, your differentials, excuse me. And then, yeah, as you said, get pretty involved with the testing and we'll say commissioning and maintenance of those relays, because as your area, just like ours, it's very old electrical infrastructure, and even though a lot of the electromechanicals, you look at them even today, and they're impressive how they're built, how they work with their discs and springs and everything. But nothing is nothing could beat Father Time. Eventually gonna always it's always gonna kind of catch up to you. I know about a year ago we had a facility that we tested some of their relays. A few of them failed, and just kind of brought it up to them that we should really look into probably changing these. They're all electromechanicals to more electronic based relays, microprocessor based relays, and sadly, eventually the relays didn't trip when they were supposed to, and they ended up knocking out their main transformer.
That's not
So what was turned into quite a sizable job, which is still continuing to this day, where we're now upgrading almost all their main incoming infrastructure. So
good. Wow.
it it was a bad, but I guess a good thing, because it helped push the point across that this stuff, because we fail it, it's not like failed because we're trying to nitpick it. It's failing because, going way back to how we started this, it doesn't meet the manufacturer specs for doing what it was designed to do. Um, so thankfully we were able to get them up and running over a year ago, and now they're running, but now we're doing the second phase of that project.
Yeah, and that's a big thing. A little bit off the topic of the relays. I think those quote unquote horror stories that you hear in the industry, and it's not just me and you. It's everywhere. Regardless of the trade you're in, everybody has their emergencies. But unfortunately, when you have an emergency pertaining to the electrical infrastructure, I would say 9 times out of 10 it's catastrophic. When electric fails, people can't see electricity. In this room right now, I'm looking at a panel across from me. You wouldn't even know it's there if it was just sitting on the wall. But if a panel fails, or a wire heats up and catches on fire, the failure when it pertains to the electrical infrastructure isn't just a matter of water leaking on the floor. It's a chunk of your building's getting taken out, or even worse, the whole building could just burn down. And I don't say that to put fear into anybody, but that's the hazard of having a larger electrical infrastructure, or even small panels in your facility. And I think the maintenance of the infrastructure as a whole is extremely important to mitigate those fires and those hazards. I think NFPA 70E states 74% of building infrastructure fires are caused from the electrical infrastructure. So when you hear that number, the odds are absolutely horrible in a building's favor to not have an electrical fire if you're not performing maintenance. So, like you just said, you guys found the fault. You came up with the course of action to mitigate a large failure. The client, for whatever reason, didn't go down that path, and now you guys are restructuring their electrical infrastructure. It sounds like.
Yeah, yeah, redoing their whole switchgear house actually. So
And what does that look like? You guys are over there. How did you get them on? Temporary power. What did that process look like to paint that picture to people that are kind of questioning these things?
it was we had to make a lot of phone calls and find somewhere that had a transformer to get them up and going, because I
Wow.
mean, it took down their main transformer. Want to say it was a 115 kV line, but I could be wrong. It could have been 38. But I mean, still, just the lead times today to buy it new is just absurd. So, and
Yeah.
someone can't wait, half a year to a year or longer. So, we luckily found a place that had one in stock. It was used, but it was still everything tested properly, shipped. We retested it all tested properly, redid all, pulled up all the conduits, redid the feeds to it to the new transformer, reset up all the alarms, programmed new electronic relays.
Wow.
Communicated with the utility, which is another big, because it was their main, so the
Yeah.
utility had to get involved and had, okay, this, you're not going to blow us up, you're good to go. So that was kind of how that whole
So yeah,
road went.
it's a major undertaking when you get involved with getting a client back online, because at the end of the day, it's like a double whammy in the sense that now they have business interruption and they're looking at the fee to replace their electrical infrastructure. So to get them back online so their business can run, in order to maintain monetary flow, it's important. Guys like yourselves and our team at Lapolis, that we can respond at the drop of the dime. And fortunately, even though the supply chain's as damaged as it is from a temporary aspect, we could at least get people on temporary power while their permanent solution is being worked on, in the interim. And that's something too, like the supply chain. You said it. The supply chain in our industry is absolutely terrible. I think after like 2020, 2019, the supply chain took a major decline, and it never fully recovered. I know like switchgear, transformers, larger generators, and the specialty applications could take up to 50 to 70 weeks to ship. Who has that much time to wait in an emergency? New construction, it is what it is. That just increases the project timeline. But if people are putting themselves in a situation where they have the opportunity to do preventative maintenance testing, de-energized, torque checks, lubrication cleaning, mechanical operations testing, and all the above, but they choose not to do it, they're almost looking to cause themselves, self-inflicted pain, in the sense that if there is a failure, there's no telling what the supply chain, fortunately you guys got a transformer fairly quick, but there's no telling what the supply chain is going to dictate when you need something.
Yeah, and and I guess, just to go back to that, just from the feat of getting all that equipment, just the impressive feat of having the guys out there, and the people in the office, everyone come together to get the customer what they needed, I think is the most impressive thing, because that stuff isn't easy to do. Not that any of it's easy to do, but it really takes a great team effort of people from inside and outside the office to come together, bounce ideas off of each other, spending time out in the field, spending time in the office, doing prints, making changes, talking with the guys, just seeing how it's all going to lay out. Because once you start pulling all that stuff through and start turning it on, and you only get one chance to turn it back on.
Yeah.
If you all weren't talking and working together as a team, as a group, one failure, it could become two failures.
Yeah, I agree that team aspect when you're on these, fast-paced emergency projects, so to speak, is so important, because every person on that team has their function, whether it's the operations, the logistics, making sure that the vendors are being contacted to order the material, getting the paperwork put together, there is so many functions within that operation that a lot of the times people don't even see because a lot of the work is behind the scenes. You'll have one or two guys on the job to figure everything out, and then in the office it's kind of like a war room. You got people running back and forth. Come look at my computer, I'll go look at your computer. People on the phone. It's definitely, in my eyes, if a customer has an emergency, we have an emergency too, because it's our obligation to get these people back online. And when everybody kind of works in line with each other and has that same mindset, that teamwork aspect is it's truly great to watch, when it's in production, even though it's for an unfortunate event, to know that we have that team aspect and that response time. It makes us who Lapolis Electric is and who Ferguson Electric is, and that's why we have people that rely on us on a daily basis to get the job done for them.
Yeah, it kind of goes to how I saw family owned and operated. It kind of goes back to that, and like then everyone comes together as a family and just works together to get it done. So
Yeah. And I think that's been, especially for Carmine and, everybody at Lapolis, that's been the motto for over, 40 years now. We've been in business. And, whenever something happens, big or small, it's all hands on deck. What do I need to do? You know, Job titles go out the window. At the end of the day, a job title is just, in my opinion, something for the bottom of your business card so other people can identify what your function in the company is. But when there's a major event, it's, all right, what do you need me to do? Do you need me to help with operations? Do you need me to put paperwork together? Do you need me to estimate? Do you need me to assist in, coordination? And it's just a matter of like, what function do I need to fit to make sure that at the end of the day the client is properly handled, and that's really what it's all about. Just backtracking a little, because we briefly touched on the relays. What type of tests when we're working on the relays, or when you guys are working on the relays, are you running? And you could use a specific relay type as an example if because I know there's so many. There's a wide variety of tests and relays. Give us some examples of tests and the benefit of performing those tests to the electrical infrastructure.
yeah, so I guess we'll just stick with the basic overcurrent because that'll be the easiest one to kind of detail through. You do your standard pickup tests, which you make sure if we're talking electromechanical, if the pickup's set at 5, that the relay picks up at 5. And then from your pickup tests, you have your timing test, which then takes into account the curve. So that then takes in your pickup, and then whatever you have your time dial set to, you inject so much current times that pickup value, and then at a certain time, it's going to pick up on a curve point. Typically, you do about 3 to 4 points, depending. Sometimes utilities want to see something different, but usually stick to like 2, 3, 4 times your current. And then then if you have an instantaneous relay, you'll test your instantaneous pickup. And then the timing is usually instantaneous, so that's usually fractions of a second test. And then if you have electromechanical, whether it's electromechanical or electronic style, you still have like what they call targets. So old electromechanical, the target is like the little orange flag. Sometimes if you walk somewhere and you see a bunch of little orange flags, that's not a good sign. That means something tripped at some point, and someone either just reset it, and thankfully they didn't know to reset that flag, because that gives you a good indication that they had a trip, and someone obviously just turned it back on without looking into that, which could cause further failure. And the same for the electronic. They just have little lights. They're a little bit more advanced. They have lights depending on what function picked up, most of them, or across the screen you could program it to kind of say, oh, it tripped on differential, so that
Gotcha.
you could walk in and see that.
And for somebody that may have relays in their facility, but they're not really too sure what some of this terminology may be, because, of course, you're an engineer and, we deal with this stuff every day. So it's, for us, it's second nature. But what does the terms pickup and short term and instantaneous mean to these, facility managers out there that may not be too sure what it is, but they should know what it is?
I guess pickup is kind of it takes into account it doesn't take into account the timing curve.
Okay,
So it's just literally that value. Um it's if it's set at 5, it should pick up at 5.
gotcha,
Um then once you get into the curve aspect, and that takes into account the manufacturer spec curve for whatever said relay it is, and that's all dependent. Such a mechanical, it's usually on the face of what the curve is, which could be anywhere from like moderately inverse to extremely inverse. And then electronics, you have the beauty of changing that curve. So that's where the other positive is, where they come in the coordination is. If you have an electronic style relay and stuff changes as everything does, you could just simply go in and change the program.
gotcha. Very interesting. And these relays are so sophisticated now in terms of their function and their operation to the overall infrastructure. What is one tip, for a facility that has relays, or if they're not aware that they have relays, what's one tip you could give a facility manager or a director of engineering, whoever may be in charge of managing that electrical infrastructure, they should do if they're aware they have relays?
I guess the first tip would be is everything clean? Because especially the whether it's electronic or electromechanical dust, and that's a killer. So if you walk into the switchgear room and it's full of dust and debris, it's probably means that first it hasn't been cleaned or maintained in a long time, and they should probably really get on the ball of someone coming in and checking out, making sure everything's going to work
Yeah, and I
when it's
think
intended to.
Yeah, and I think for us, we could speak on behalf of Lapolis Electric, Ferguson, and the overall Teg network. If you are in need of an overall site evaluation, there are men and women like us out there that can go into the facility and make those proper recommendations for people. So they are aware of the overall condition and the implementation of a program, so to speak, to make sure that their facility is operating efficiently and safely. Um, One other quick thing, I know we didn't really touch on it much while we were chatting, that I want to bring up is transformer testing. Just give a quick overview on your experience with testing transformers and how important that is to the overall electrical infrastructure. Obviously the relays have their function, but transformers and the changeover of voltage and the importance that they play in the overall flow of electricity. How important is it to make sure the transformers are properly maintained every 3 to 5 years?
Well, I would say it's pretty important. I mean, that's like more or less the lifeline to a lot of facilities. If regardless of your coordination, if that transformer goes down, odds are it's your main or somewhere that feeds a very large piece of distribution. And new or old, as I was telling you earlier, we had one about a week ago that was a brand new transformer. We went out, tested it, had some erroneous results. We all questioned it. This thing's brand new. How could this be? We all thought someone screwed something up somewhere.
Yeah.
Not maliciously, but did we enter the nameplate data right? Did the leads go on to the right part of the transformer? And it came to find out after we took an oil sample that there was already moisture in that oil. So that then led to believe that, and I believe it was a bushing that wasn't perfectly sealed and seated on that transformer. So not only is old equipment, but new equipment before it goes into service, especially transformers, they're heavy. There's a lot of pieces in there from transporting. Usually, once before it leaves the factory, they'll do a bunch of acceptance tests, and then you should ask for those tests once it comes on site, so that then you can perform your own to then verify that nothing shifted internally in the transformer before you just connect up and turn it on.
Gotcha. That's really important. And that's a big topic we talk about here, especially after a building's built in New York City, or whether we're working in Manhattan, New Jersey, Westchester County, doing our testing, and we talk to newer facility managers that are running these buildings that just opened up, and they said, "Nah, the building was just built. We don't need to test it." There's times where we go in and more than just the transformer, but we test the overall infrastructure, and we find problems, multiple problems throughout the infrastructure. And, a lot of it's related to construction conditions. Like you're saying, it's job sites are very dirty, they're very dusty. It may not even be the fault of the electrician. There's dust built up, people just throw stuff in the electrical closets like it's a garbage chute. And these conditions that are created damage the infrastructure from day one. And a lot of the times when buildings are being erected or heavy equipment's coming in through cranes or however, there's vibrations being sent through either the steel or the concrete in the building. And even though we may not be able to feel those vibrations, it affects the internal mechanics of the electrical infrastructure. Parts move, parts loosen, and a building that may only be open for a year could be exposed to hundreds of problems that somebody's not even aware of.
Yeah, and even from the sense how a lot of people now go to like the metal framing.
Yeah.
Those shavings go anywhere. And they get picked up by the wrong piece of equipment or swept into the wrong area. Or they think it's cleaned up.
And it's not.
It travels quick.
It does. It travels very quick.
You find out quick.
So let's get one more hot tip from you, for those facility managers or, building engineers that may be listening to this podcast today. From an overall preventative maintenance standpoint, whether it's transformers, relays, switchgear, distribution panels, whatever you're managing, whatever's in your infrastructure, what's one tip you could give people to mitigate electrical fires, hazards, and building interruptions?
I guess I would just say if you're unsure of the last time it was tested, or you're unsure of the quality of testmanship that was done, probably pick up the phone and call a qualified testing outfit like a TAG affiliate or something, to come on in and do a look around.
Yeah, I think that's great. Great advice. And I'm not just saying that because I do it every day, but it's, there's so much hazard involved that these overviews should be done based on, the standard that NFPA 70B is setting forth in their frequency tables. And if you're wondering what those frequencies are, for infrared, it's annually, de-energized maintenance every 3 to 5 years. Arc flash hazard analysis should be performed every 5 years from its baseline study. And the protective relays are supposed to be done every 2 years. And this knowledge and understanding that, like you said, the TEG affiliates have of the infrastructure, whether we're in, New York City, Buffalo, Arizona, Michigan, wherever we are, Texas, all over the place, all 50 states, a couple different countries, we'll have the proper staff come on site and develop those programs for you to make sure your facility is operating free of electrical hazard. So Patrick, I want to thank you for taking this ride down to southern New York.
Yeah, thank you.
And
Appreciate it.
Get a little bit of a taste of the New York City traffic coming from the airport the other day, and working with our team and coming on to the podcast to provide your expert overview of what we deal with on a daily basis.
Yeah,
So thank
you're
you for
welcome.
coming
Thank
down.
you, Stephen.
Much appreciated. And with that, thank you for watching another episode of the Beyond the Blueprint podcast, powered by Ferguson Electric. I'm your host, Stephen Marcelino. Have a great day.